Hello everyone. In last video we saw how to deal with binomial coefficients within single summation, and in this video we will explore how to handle double sigmas. So let's start. Now here we have a double summation which is summation I from 0 to 2, summation j from 0 to 1, ai into bj. Now double summation means that we need to have all the combinations of these summation. For example, here we need all the combination of I and j, where I is in range 0 to 2 and j is in range 0 to 1. So to write all the combinations, I have created a matrix where I where is in the horizontal direction and j where is in the vertical direction. So these are the 6 combination that we get from this range. Now we need to add all of these 6 values to get the value of this double sigma aibj. Now also there is an important property for products. If we have summation, double summation I and j and something into something, where this is dependent on only I and this is dependent on only j, so we can break it into basically we can take this I term out of this summation, as it is only dependent on I, so this is constant for this inner summation, so it can be written as summation ai summation bj if we consider this values. So this will be I equal to 0 to 2 and j equal to 0 to 1, and we can now open it easily. So this will be a0 plus a1 plus a2 into b0 plus b1, and if we multiply and open this complete product, we will get all these 6 terms. Now for summation also we have a similar property, that is, if we have summation I equal to 0 to 1, j equal to 0 to 2, ai plus bi, then we can split it as summation I equal to 0 to 1, summation j equal to 0 to 2, ai plus summation I equal to 0 to 1 and summation j equal to 0 to 2 bi. So these were the properties for summation and products, or similarly for if it was subtraction also. So what we did here was that both the sigmas were independent of each other. For example, I and j here has no dependency on each other. So this is known as disjoint sigma. Right. Now let's see what are connected or joint sigmas, where we will have some condition on I and j. For example, I should be less than j or something like that. So let's see that now. So in connected sigmas, here we have certain conditions which limit the search space. For example, here we have I and j that must be between 0 to 2, but another condition is that I must be less than j. So this is the condition. Now if we create the matrix where we have I and j, so this matrix contains all the combination of I and j in this range, but only these three terms are the ones that we need for the summation, as only these terms have I less than j. As in this diagonal, I and j are equal. In this diagonal, sorry, in this lower triangle, I is greater than j. So this is the only region where we get the required terms. So in all such questions where we have connected sigmas, we need to create the matrix and look for the specific terms that we need. Right. So now let's see the questions on these types of summations, and basically we will be dealing with these questions only, and we will be using this disjoint sigma concept to solve the joint sigmas, right? So this types of sigmas are known as joint or connected sigmas, right? So now let's see a question. So the question is, we need summation ci cj where these are binomial coefficients and the limit is 0 greater than equal to I, less than j, and less than equal to n. Now let's solve it. So to solve this, first we need to create the matrix. So let's create a matrix where we have j equal to 0, j equal to 1, j equal to 2, and so on up to j equal to n. And on the vertical axis we have I equal to 0, I equal to 1, I equal to 2, and so on up to I equal to n. Now here we have C0, 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 C1, C0, C2, and up to C0, Cn. Then here we will have C1, C0, C1, 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 C2, and so on up to C1, Cn. Similarly, we will fill this matrix till Cn, C0, Cn, C1, Cn, C2, and up to Cn, C. Right, so we have filled this matrix. Now what we need is I should be less than j, and can you figure out where we can find it? It is here only, this upper triangle, this one. Here we have I less than j, and in this diagonal we will have I equal to j. Here it is I less than j, and in this lower triangle what we have is I greater than j. Right, so what we need is the sum of this upper triangle. So now if you observe, the lower triangle and the upper triangle are exactly similar, as you can see this is C1 C0 and this is C0 C1. They are just swapped. These both terms are just swapped. Here also this is what Cn C0 and this is C0 Cn. This is Cn C1, this will be C1 Cn. So these are exactly same. And similarly all of the terms in the upper and lower triangle will be exactly same. So now what we need to find is the complete matrix minus the diagonal divided by 2. This is what we need to get the upper triangular sum, right? So as you know that what will be the sum of this complete matrix, that will be sigma ci cj and I equal to 0 to n, j equal to 0 to n. The disjoint sigma gives the sum of all the values in this matrix, the basically the complete matrix summation. So what we need is this summation minus where I is equal to j. So as you can see, this is what c0 square plus c1 square and so on up to cn square. So we need to subtract summation ci squared and I equal to 0 to n, and this divided by 2 will give us the final answer. Now we will use the product property so we can get this out of this summation. So this will be summation 0 to n ci into summation 0 to n cj minus summation 0 to n ci square divided by 2. Now summation of ci from 0 to n, this will be 2 to the power n into this will be also 2 to the power n minus summation ci squared from 0 to n is 2n cn, and this is divided by 2. So this is equal to 2 to the power 2n minus 2n cn divided by 2. So this is the final answer. Now these results we have already derived in our last video, right? So now let's talk about the final results that we observe from this example. So these are that total is what, twice the triangular portion, the upper triangle and the lower triangle, plus the diagonal portion. Right now the total part, the complete matrix summation is what, disjoint sigma, and the diagonal part is normal, where I equal to j. So at the end we need is the triangular portion, so that will be the triangle part is what, total minus this diagonal divided by 2, and total is what, double summation disjoint minus summation where I equal to j divided by 2, and this is equal to the connected sigma. So this is the final result that you need to keep in mind to solve all the questions. Now let's see another example. So this is summation ci plus cj and 0 greater than equal to I less than j less than equal to n. Right now let's see the matrix again. So the matrix will be c0 plus c0, then c0 plus c1, so on up to c0 plus cn. So here I and this is what j. Right now here we have c1 plus c0, c1 plus c1, so on up to c1 plus cn, and this will go up to cn plus c0, cn plus c1, and so on up to cn plus cn. So this is the complete sigma. Now what we need is I less than j, which is this portion, and this is the diagonal, and this is the lower triangular part, which is exactly same as the upper triangle part. As you can see again, this is just swapped here. Now the total summation is what, sigma I equal to 0 to n sigma j equal to 0 to n and ci plus cj. Ci can be written as ci into j to the power 0, right, and cj can be written as cj into I raised to the power 0. So what we can do is we can split this sigma on double sigma. Let me write it, then you will understand. It is double summation Ci plus double summation Cj, and this will be I equal to 0 to n, j equal to 0 to n. Similarly, this also. Now, why I wrote this is to make you understand that how this will be solved. So we can write it as j to the power 0, and this is also I to the power 0. Right now, when we put all the combination of I and j in this, so what we will get at the end is, this is power 0. So at the end, any value of j will reduce to 1. So this is Ci, and any combination will lead to 1 only. So basically we are just putting all the values, and what we get is Ci summation I equal to 0 to n, and summation 1 j equal to 0 to n. I just use the product property here. Then this is what 2 to the power n into, this is what adding uh 1 0 2, and these are n plus 1 terms. So adding 1 n plus 1 times gives us n plus 1. Now this is also same, 2 to the power n into n plus 1. So I hope you understood how we can solve this on plus operator. Basically we can just split this complete double sigma on each of them, and then what each of them means is that Ci is multiplied with 1, and 1 is what, j to the power 0, and we can independently now take this out of this summation, as this is disconnected sigma, and we can just then use our basic sigma rules to solve it. So we have the total now. Total is equal to 2 to the power n, adding both of them we will get into n plus 1 into 2. This will be 2 to the power n plus 1 into n plus 1. Now what we need is the diagonal. So this is summation 2 ci I equal to 0 to n. As you can see, each of them is, this is 2c1, this is 2cn, and so on. So I have written it like this. Now this is equal to 2 summation ci 0 to n, and this is what, 2 into 2 to the power n, which is 2 to the power n plus 1. Now we can get the final answer, which will be total minus diagonal by 2. So 2 to the power n plus 1 into n plus 1 minus 2 to the power n plus 1 divided by 2. So this will be equal to, we can cancel this 1 and 2 to the power n into n. This is the final answer. If you have followed till now, you must have understood the core concept behind solving these questions. That is to create the matrix for the disjoint summation, and then get the required part. Now, if the expression is symmetric, and symmetric means that if you swap I and j, you get the same expression again. For example, if we have I into j into ci into cj, now if you swap I and j, you will get j I cj ci, and that is exactly same as this. So in that case, you can always assume that the lower triangle is will be equal to the upper triangle, and you can directly apply the formula, that is total minus diagonal divided by 2. Now this diagonal can be found by just putting I equal to j. Right, so now let's solve the question without using this matrix. But note, this is a general way to solve any double summation question, and this is applicable on any question. But this is only true if the expression is symmetric. Now let's see some examples. So the question is summation I into j into ci into cj 0 greater than equal to I less than j less than equal to n. Now the total is equal to, we can just use the disjoint summation, that is I equal to 0 to n summation j equal to 0 to n I j ci and cj. Now we can use the product property and put this out of this summation. So this is equal to summation I into ci 0 to n into summation j into cj 0 to n. Now this is equal to n into 2 to the power n minus 1 into n into 2 to the power n minus 1, which is equal to n square 2 raised to the power 2n minus 2. Now to get the diagonal part, we will put I equal to j. So we get I square ci square summation 0 to n. Now this is equal to n square into 2n minus 2 cn minus 1. So this also we have discussed in our last video. Now we have the diagonal part also. So the result is equal to total minus diagonal by 2, which will be n square into 2 raised to the power 2n minus 2 minus n square 2n minus 2 cn minus 1 divided by 2. So this is the final answer. Now let me write some questions and you can try it yourself. They are also fairly easy and you can solve them. So these are summation I and ci square plus cj square. Similarly, and I ci square plus j cj square. Now let's see the unsymmetric type. So here you can see in unsymmetric type, if you replace I and j, so you will get a different expression, not I and cj. Now in such questions, we need to go back to the basics and create the matrix and see what is required and then solve them accordingly. So I've already created the matrix and here we require I less than j. So this part will be I less than j. This row, then this, then similarly all till end, right? So this will become 1 into c2 plus c3 so on till cn plus 2 into c3 plus c4 so on till cn and up to n minus 1 cn. Now solving this is a little difficult because you need to add and subtract c0 c1 and in this you need to add and subtract c0 c1 c2 and so on, and even then it is really difficult to solve in this way. So what we can do is we can see this thing vertically like this. This is one portion, this is the second part, similarly the third part and so on till the last part. So if we visualize this in this way, then what we get is C2 into 1 plus C3 into 1 plus 2 plus C4 into 1 plus 2 plus 3 and so on till Cn into 1 plus 2 plus 3 till n minus 1. Now this is a little easier as we can write its general term, which will be Ci, and we can write this summation using the formula, which will be I minus 1 into I divided by 2. And what we need is we need to add all of them. So this will be summation. I is what from uh, we can keep it as 0 to n, because if we keep 0 this will be 0 and this expression will become 0, so it doesn't matter. And even for 1 this term will become 0 and overall term will become 0, so we can write it as 0 to n, so that in later steps we can get the complete summation series and we can use the formula directly, right? So this is a general term and we now can just split it, it will be summation 0 to n ci into I square minus I, and we can keep the 1 by 2 outside, so this will be 1 by 2 into summation I square ci 0 to n minus summation 0 to n I ci. Now these are the results, we can directly use them. Now this is 1 by 2 into n into n plus 1 into 2 raised to the power n minus 2 and minus n into 2 raised to the power n minus 1. So this is the final answer. Now let's see the second example, which is this one. Here also I have created the matrix. Now this is NCJ and JCI. Now here you can observe that the lower triangular part does not exist, as here J is less than I. So JCI is not defined. Also this is also not defined, as 0C0 is undefined. So only this part remains, and in that we want the upper triangular part, right? So now let me write this here. So this I will write this vertically so that we can solve this, as if we see it horizontally then there is nothing common and we cannot solve it. So I am writing it in this way. So this will be NC1 into 1C0 plus NC2 into 2C0 plus 2C1 plus NC3 into 3C0 plus 3C1 plus 3C2 and so on till NCN NC0 plus NC1 till NC n minus 1. Now as you can see these are normal series, but some terms are missing, so we can just add and subtract them. So here we will add 1c, oh sorry, yeah, 1c 1 is should be added and we can subtract 1c1. Then here we can add 2c2 subtract 2c2, then here also 3c3 minus 3c3. Similarly till end we will add ncn and minus ncn. Now this is equal to nc1 into 2 raised to the power 1 minus 1 plus nc2 into 2 raised to the power 2 minus 1 plus so on till ncn 2 raised to the power n minus 1. Right now we can club the 2's power terms and the subtraction terms. This will be nc1 into 2 plus nc2 into 2 square plus so on till ncn 2 raised to the power n and minus nc1 minus nc2, let's write this in bracket, plus nc3 and so on till ncn. Right now this is like a binomial expansion of 1 plus x raised to the power n, but what is missing is the c0 part, so we will add and subtract it. So let's add it, nc0, and we can just write a minus 1 here. So this becomes 1 plus 2 raised to the power n, and this is the normal series summation ci, but the nc0 term is missing, so we can write this one as nc0, and we can just club them together and take this in the bracket. So this will become 2 raised to the power n. So now we can just solve it. It will be 3 raised to the power n minus 2 raised to the power n. This is the final answer. Now let's see the last type for this video, which is how to solve multiple sigmas and where we have a constant as the value. For example, if we have summation 1 I less than j less than equal to n. Now how can we solve this? So you know how the longer method to create the matrix and solve it, but let's see how to solve this quickly. So we can do this using permutation combinations, as this can be written as summation I to the power 0 into j to the power 0, right? 0 I less than j less than equal to n. Now what this means is that for like each valid pair, for example 1 comma 2, it will be 1 to the power 0 into 2 to the power 0, which is 1. So basically each value will be 1, but how many times you have to add 1, that is the required answer. So uh, the number of valid combination of I and j that satisfy this constraint is the answer. Now how can you find that? So to find that, what we will do is we will choose, here we have only ij, so we have two variables, so we will choose two values, in the range 0 to n, and we will arrange them only in one way, that is I comma j, where I is less than j. So we have to choose two unique values and just arrange them in ascending order. That is only one way. So how we can choose two unique values from n plus 1 values, as we have 0 to n numbers, so so it is n plus 1 numbers. So the way to choose two values from n plus 1 numbers is n plus 1 c2, right? So in this way we can choose two unique values from n plus 1 numbers, and after choosing each pair of number we can assign the smaller one to I and larger one to j. This is the way to solve these type of questions, right? So let's see another example. If we have summation and 0 less than equal to I, j, k, l less than equal to n. So this is a constant 2, we can get it out of the summation. So let's write here 1 and 2 out of the summation. Now it is the same question. So we have to choose 4 numbers from n plus 1 numbers. So that will be 2 into n plus 1, 3, 4. And this is the answer. Now it can be any number of summations. You just need to solve it using PNC. Now now let's see what will happen if we have some equal to's in between. So let's say we have summation 1 and 0 less than equal to I less than equal to j less than equal to k less than equal to n. So here we can create different cases. So the first case will be I less than j less than k. So here we just need to choose 3 numbers from n plus 1. N plus 1c 3. Another case is I equal to j and less than k. So here we will just choose 2 numbers and assign the smaller one to I and j and the other one to k. So it is n plus 1 c 2. Then I less than j and equal to k. Again same again we have to do n plus 1 c 2. Then the third case will be all equal. So that will be I equal to j equal to k. So we need to choose only one number. So it will be n plus 1 c 1. Right. Also one case we have missed, that is I equal to sorry, that case is not possible. That is, as this is only possible if j is in between k and I, and this is only possible if all are equal. So we have handled that case, so we can ignore this case. So the final answer is sum of all these. Now let's see the last question, that is I equal to 1 to n, j equal to 1 to I, and k equal to 1 to j and 1. Now try solving it yourself. So let's solve it. So as you can see, you must not forget your basics, which is this all are disjoint sigma, and this is a constant. So it can be solved easily. It is just summation, and this one is adding 1 j times, so it will be j, and this is from j equal to 1 to I. Now this is the sum of natural numbers, which is summation I into I plus 1 by 2 from 1 to n. Now you can just multiply it and solve it. So I hope you understood how to solve these multiple summations and double sigma, and in the next video we will learn how to solve telescoping series and how to solve questions which have limits in it, which can be reduced to integrations. And in the last video we will see some miscellaneous questions where we will use different concepts from all parts of maths to solve those series. So thank you for watching. See you in the next video.